All right. Welcome to Pomodoro Joe for Sunday, February 26th, 2023. Today we're doing LeetCode problem 72, edit distance. We got a hard one today. Given two strings, word1 and word2, return the minimum number of operations required to convert word1 to word2. You have the following three operations permitted. You can insert a character, you can delete a character, or you can replace a character. And that's it. All right. Well, with that, let's get started. Put 25 minutes on the Pomodoro timer. All right, if you watched my videos before, you will know that I am a fan of recursion. So I think we will do this one recursive style. So first we'll have a result and we'll set it to 0. And we will return the result at the end. All right, so in recursion, what's the first thing we always do? That's right, we write the base cases. So what are our base cases here? Let's see. I'd say our main base case is what if word1 is already equal to word2? That's an easy one. Okay, so if word1 is equal to word2, we just return 0 and we are done. What are the other base cases? Well, let's see. We're trying to make word1 into word2. What if word1 has no characters in it? It's just an empty string. So then we need to add all of the characters of word2. So if word1's the empty string, then we need to add every single character from word2, which is basically the length of word2 operations. Okay, and I think the same will apply in the inverse situation. If word2 is the empty string, then we'll have to remove all the characters from word1. Okay, so we got our base cases. We have the words are equal, word1 is the empty string, or word2 is the empty string. Now we need to create our recursive cases. So in any recursive problem, your goal is to break down each step into a small piece of the problem and then let the recursive call do the rest of the problem. So in our case, our small piece that we're going to break this down into is just comparing one character. So which character should we compare? Let's just compare the first one. Make it easy on ourselves. So if word1 at character 0 is equal to word2 at character 0, well then we just need to compare the rest of the word. So we already know that the two first characters match. Let's just compare the rest of word1 to word2. And to do that, we make a recursive call. And our arguments to the recursive call will be word1 from the first character to the end, or sorry, from the second character to the end, character at index 1. And word2 from character at index 1 to the end. So we just basically ignore that first character and we compare the rest of these two words. Now, if they aren't the same, that's where it gets tricky. So if the first character of each word is not the same, we basically have three options. We can insert, we can delete, or we can replace. Let's explore each one of these options. So if we insert a character, we'll be inserting a character into word1. So in that case, let's see, we'll have option 1. So that will be one operation because we're inserting, that's an operation. And we'll do a recursive call. So what do we pass in for our arguments in this recursive call? So we're inserting an element, we're inserting a character into word1. So essentially we're just saying we need to make our first character of word1 equal to our first character of word2. We're basically creating this situation. So we just need to do the same thing we did before. So we have one operation plus making the rest of the words match. Okay, what about deleting? So that's option 2. we do one operation to delete a character, and of course we're deleting the first character of our word 1. And so then we just have to do the same thing, make sure that the rest of word 1 matches word 2. Now what about replace? Option 3. Again, this will be 1 plus. Well, look at that. It's exactly the same. Something about this doesn't look right to me. Let's see here. So for inserting, we're going to insert some character into word 1. Ah, that's what I'm missing. So if we're inserting the character into word 1, we'd basically have to say word 1 is equal to word 2's first character plus word 1, because we're inserting some character. So in that case, we can just say, well, we've inserted the character to match, so we don't need to actually do this. Yeah, that's what I was missing. Something didn't look right. So in this case, we're inserting a new character into word 1. So that means the remaining part of word 1, which is just our existing word 1, has to match the remaining part of word 2. Now with delete, it's similar, but slightly different. We're deleting something from word 1, so we're going to delete that first character from word 1. And that better match the rest of word 2. Okay, that makes more sense to me now. In option 3, we're just going to replace word 1's first character, and so the rest of word 1 better match word 2. And finally, we will make sure our result is just the minimum of these 3 options. All right, and then we return the result at the end. Okay, let's see how we do. Okay, we're passing. Let's see if we can pass the entire set of tests. Ooh, and we run out of time. We only beat 24 out of 1,146 test cases. Wow. So we definitely need to speed this guy up. Okay, what can we do to speed this up? Here's a very, very simple thing we can do. So we've got 2 words, these are just strings. If we were to cache our results from, as you can see, we're kind of making some similar calls, like this call, and we might make this call again. If we cache our result, then the next time we call a recursive call, we could just skip doing the processing and just return the cached result. Now, one way you can do that is with dynamic programming. We can create a dictionary that keeps track of our inputs and stores the outputs, but we don't need to do that by hand. Python has this amazing class, or this amazing library called functools. So from functools, we will import cache. And cache is a function decorator that will essentially do our dynamic programming for us. It will store these inputs as our key and the result as the value, and anytime we have the same inputs, it'll just return that value without having to do this recalculation over again. So let's try this, make sure this still works. Okay, that still works, and let's see if we can maybe pass all the runtime requirements. Not only do we pass, look at this. We pass and we beat 77% for runtime and 5% for memory. That's not too bad for making this one little change. Now, if you want to make this even better, you could try doing your own dynamic programming. You might avoid this whole import, which could save time. You might also save some memory if you do your own caching. But not too bad for our basically first pass. Okay, there's one thing I do want to try. Let's give this a shot. So one thing here is we're saying if word 1 has the same first character as word 2, then we'll just do this recursive call. We could also say while word 1 has the same first character as word 2. So we can basically jump ahead if we need to. So let's try something like that. So I'll have index equal to 0. All right, so we're just going to scan ahead until we find a word or a character that doesn't match. And then, all right, quick little voiceover here. So the goal with this segment was to essentially skip all of the matching characters from the beginning of each word just by iterating through, keeping track of the index, and then you can just process from there. However, keeping track of the indices, making sure you don't go out of bounds, is a little bit more complicated than I expected. Okay, let's try this. I am not convinced this is going to work at all. It works, but we do terribly. We only beat 26% for runtime and only 5% for memory. All right, so our best solution was still our initial solution with the caching. Okay, you have a lot of room for improvement on this one, so I totally recommend you check this one out. Try it on your own, see what you can do. I bet you can beat my score by a lot. All right, thanks for watching. Hope you enjoyed this. Hope you had fun. If you did like this, please subscribe. Please give me a thumbs up and check out my other videos. All right, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something, and hope you can write better code. Just realized I have a couple minutes left. I'm going to try something just to see if this makes any difference. So instead of checking if the first characters are the same and doing the recursive call here, let's move this to the end. So this will be our default, and we'll only run the other recursive calls if the first characters are not the same. Let's see if that makes any difference at all. Oh, it does, because we get a wrong answer. Oh, I need to return the result here. That's why. Try that again. And in fact, we could even remove the result and just return this. That might save us a little bit. Okay, that's a little bit cleaner. Let's try this. $79, creeping closer. So we went from 77 to 79. Oh man. All right, one last thing here. Let's do the DP instead. Remove this cache. We're going to do our own dynamic programming. All right, so the key with dynamic programming is we need to keep a key value pair, and we'll check it right away. So we can actually get rid of this result. We don't need this. And we'll say our key is going to be just our word 1 and word 2 as a tuple. And then we can check if key is in our DP. Then we just return DP at that key. Otherwise, whenever we do a return, we just have to make sure we set our DP first. So DP for our key will equal what we would return, and then we can just return our DP at that key. Same thing here. Okay, so now we're doing our own dynamic programming. We're skipping the cache. Oh, I need to make this self. Sorry about that, folks. Try that. That should be better. Okay, let's see if our own dynamic programming does any better than the caching algorithm from the functools library. And it does. We are up to 92% for runtime and 7% for memory. Significant improvement over a cache. So cache was 77%, doing our own DP, 92%. Okay, now with that, I am done. Hope you enjoyed this, hope you had fun, hope you learned something. Please like and subscribe and try this on your own. And when you do, please write better code.